Okay, according to my clock, the official time has arrived, so let us begin. Good morning, welcome. My name is John Ostlund, and this data-focused Python course is going to be an intensive introduction to Python. Our assumption here is that you don't know Python necessarily, but that you are an experienced programmer in some language. So we're going to start with very basics, and we're going to go as fast as we can, mostly concentrating on various ways of obtaining and massaging and analyzing data. So, is everybody in the right room? Too early in the morning. Everyone's scowling. Okay. My name is John Ostlund. I may have said that, but now I've said it again if I did. Let me begin by just describing the, how you're going to be evaluated for the course, because everyone's always interested in that. And it also gives me a chance to talk about how the course is organized. There are some reference materials that you can look at that I recommend, and in fact I require you to take a look at this Python for Data Analysis book, but I want to say that the first two of these references, Python for Data Analysis and Automate the Boring Stuff with Python, those are both available for free. The first one is available through the Carnegie Mellon University Library. If you just Google for Carnegie Mellon University Library and then search for Python for Data Analysis. You want the second edition. The library has both the first edition and the second edition, and you'll be able to just look at it on the web. Automate the Boring Stuff is also just available online. You can buy a physical copy, or you can just look at the online copy. The third book, starting out with Python, is a very widely used, very popular, relatively slow, very introductory book for programming with Python. It's a honest-to-goodness textbook intended for colleges. Consequently, it's wildly expensive, and perhaps you can just forget about it. It's like $100 or something. Okay, now we're going to be using for this course something called Anaconda 2019.10. Make sure that you use the Python 3.7 version of Anaconda. So Python 3.7 is the language that we're going to be using. Anaconda 2019.10 is a package including the Python language and including a whole bunch of other libraries and add-on facilities that are popularly used with Python for doing things like statistics and creating user interfaces, creating web interfaces, doing statistics, and so on. Okay, now there are basically going to be three parts to what we're going to be asking you to do and how you'll be evaluated. There will be homework every week. Except for week 6, okay? So weeks 1 through 5 will have homework assignments, and what I'm going to do, which I meant to do already and forgot, is I'm going to split everyone into pairs randomly, so that you'll have each week you'll have some random partner to work with. What I recommend for doing homework is that you do the homework yourself as much as you possibly can, and then compare what you and your partner have done and decide which of you has a better approach to things. It's always valuable, in my opinion, in coding in general, to compare your work with somebody else's work so that you can each get good ideas from each other. Then, between you, decide which of you, decide what version of the homework you want to submit along with your partner. Okay? You need to get 90 points out of 100 to get an A on the homework. don't think anyone's ever got less than an A on a homework. You do need to work hard. You do need to understand what's going on, but we assume that you're going to be successful. The purpose of the homework is to learn the material and practice the material and so on. There will be quizzes every other week, so weeks 2, 4, and 6, and those will account for a third of your total grade, roughly 35%. And those are pretty challenging, and those are obviously independent work. Now, they are open book, open system. You're going to be allowed to use the Python development environment of your choice during the quiz. You're going to be able to look things up online and so forth. But the quizzes are challenging, and there's a strict time limit. So even though you have access to resources, you've got to keep moving along to get through these quizzes. Then, half of the grade is going to be based on your performance in a group project. And I'm going to randomly assign everyone to a group of approximately 4 people. I will give all of you a week to decide to change groups if you want to change groups. But after the first week, the groups have to be stable. And what you'll need to do is to create a Python application within the group that downloads data from several different sources, that analyzes that data in some interesting way, and that displays some useful decision-making information to a user. There's a lot of flexibility in how you go about deciding, what your okay, brain freeze. What your application area is. A lot of variability in deciding where you want to get your data from, what tools you want to use to approach developing your application. And then during the final week of the course, during week 7, each group will have probably 14 or 15 minutes to present what they've done to the rest of us. Okay? Any questions so far? All right. I am available, by the way, more or less all the time. I tend to start looking at my email at around 8 or 9 in the morning, and usually take another peek at it later in the evening at least. And I try to be as responsive as I possibly can. You don't need to, if you have a question on the weekend, by all means, email me your question. Generally, when I'm teaching, I'm on all the time, including Saturdays and Sundays, and I'll try to get back to you as quickly as I can. Every so often, just because of the volume of email that I get, I'll miss somebody's email. So if you send me an email and you haven't heard back from me in a couple of days, don't be shy about sending me an email again, and I'll get back to you as quickly as I can. I will have physical office hours in my office up on the 3rd floor every Sunday from noon to 4. And I'll try to stretch those office hours a little bit. My wife is recovering from her 2nd knee replacement surgery, and that has a couple of consequences. First of all, I have to leave my cell phone on, which you shouldn't do, but I have to. And secondly, it does crimp me a little bit as far as how much time I'm physically able to be here in my office. But I'm, as I say, I'm available to answer questions by email, and we can also set up like a Google Hangout connection and so forth all the time. Good? Okay. What else? Okay, I don't think there's anything else in here that we need to look at. So let us get into Python. I am, by the way, recording this lecture, so you'll be able to hear my voice and you'll be able to see what's on my screen. And I will post this recording, if not during the middle of the day, then this evening, so that you'll be able to refer back to what I say and things I write on the screen later on. Okay, so let's get into looking at the fundamentals of the Python programming language. Python, like many modern languages, is intended as a multi-paradigm language. You can use it as what's called a traditional top-down functional decomposition kind of language, or you can use it as an object-oriented kind of language. Its primary benefit, which has made it wildly popular in the last few years and accelerating in popularity, is that it's much easier to write code in Python than in more traditional, somewhat older languages like C++ and Java. Just out of curiosity, how many of you have sat through a Java class? Most of you? Or how many of you know C or C++ or something like that? Okay, so pretty much everybody in here has written code in some language. Because of the speed with which you can write Python, it's really great for rapid development. The concern in programming is efficiency. But there are at least two dimensions to efficiency. One efficiency, which C++ and Java and other languages really focus on, is efficiency of execution of the finished program. But the other efficiency that bosses frequently care about a whole lot more is how soon can you get something done that works? And the rule of thumb is that people have done some studying and discovered that people can typically get a working Python program done in about a third the time that it takes them to get the equivalent program done in a language like C++ or Java. Okay, if you have a program that really has to execute fast, then you can start with your Python working program and use that as a model for then moving it over and changing it to something like Java or C++. Now, my personal belief, which you are entitled to completely ignore, is that big Python projects are going to be really hard to maintain in comparison with big C++ or Java projects. Because the C++ and Java code is very strict, has very tightly controlled interfaces, whereas Python is very loose about everything. So I believe, without much direct evidence, that really massive Python projects are probably harder to maintain going forward than similarly massive C++ or Java projects. Having said that, apparently YouTube is all Python, so I guess that's a pretty big counterexample. Python is an interpreted language rather than a compiled language, and this is responsible for some of its slowness. Now, despite that it has a cute little pair of snakes as its icon when you look at documentation, it actually was named for the Monty Python British comedy troupe rather than for the snake. And it is considered cool to give examples of Python code when you're trying to explain something to somebody using a reference to a Monty Python skit. So you'll occasionally come across these sort of strange references to things that may not make sense to you in documentation examples. Python was originated by a fellow named Guido van Rossum, who has been designated as the BDFL for Python overall. BDFL stands for Benevolent Dictator for Life. And in addition to Python having this overall BDFL, most big projects such as Pandas or NumPy have BDFLs of their own. There is a group, the Python Software Foundation, that now decides what is officially Python. But Python development is going on constantly. Python is changing to greater and lesser degrees more or less constantly. And so another thing that you're going to discover that is a little frustrating about Python compared with languages like C++ and Java is that you can often run into collisions between, you know, the most recent copy of a library versus a slightly older copy of a library behaving in different ways. And if you do have a big project and the different libraries that you're using are not all of the same generation, you know, weird things will break mysteriously and so on. So that can be a bit of a problem. There are many ways of obtaining and installing Python. I recommend, and I will assume, unless you can give me a really, really, really good reason otherwise, that you've got Anaconda 2019.10 installed in your system. This will work both on Windows and on the Mac, although there are some, once you've got the things installed, there are some differences in how you access them. All right, so I have my Anaconda installed on Windows 10, and I have, by following along with an installation video that I have created and posted in the announcements, put my Anaconda prompt icon in my taskbar at the bottom of my screen. So let me start an Anaconda prompt window by clicking that icon. Okay. Here we go. And if you haven't set this up for yourself yet, you know, you can do that. Do that soon. Remember that everything I'm doing here is being recorded, so you can refer to it again later. And within this terminal, I can now run various Python interface programs. Jupyter is a popular sort of web-based interface for interacting with Python code. Spider is also very popular. The one that I'm going to use is a really trivial one called idle. You really may not like idle, and I don't blame you, because it's very, very simple-minded. But I like to use idle for my demonstrations because it doesn't have lots of tiny little icons everywhere on the screen. It's just a very simple vanilla interface. Okay, so I'm going to run idle, and there we are. There's my idle window. And I'm going to stretch it across my screen. Okay, and the first thing you'll notice, the first thing that I noticed this morning, is that I actually forgot to update my copy of Anaconda on this system. So I'm using a version of Anaconda that's 2 generations old. But that really won't matter for anything that we're going to do today. And I will update my Python later today. Okay, so in this idle window, this triple greater than symbol is the Python prompt. And it's waiting for me to type Python code. Whoops. An obvious example of Python code would be something like a gets 123. What I'm doing here is creating a variable called a, and I'm using the assignment operator to cause this variable a to refer to an integer value 123. In the interactive shell, if you type the name of a variable right at the prompt, it will simply display back to you the value that that variable currently refers to. You can do arithmetic. So if I say a plus a, this is going to compute 246 and display that value back to me. A itself was not changed by doing that. Eventually, if I want to quit, I type quit with a pair of parentheses. All right, let me do it without the parentheses, just for gags. Okay. normal human beings tend to be really annoyed by programs. And this is a classic example why. I typed quit and hit the enter key. And idle comes back to me and says, hey, I know what you're trying to do, but you typed it wrong. So you have to type quit. You have to type quit with parentheses in order to get out of Python. So I'll do that now. And I'm asked, do you want to kill the program? The program is still running. I'm going to say cancel so that I can stay in my Python interface. Okay. So the equal sign does assignment. The equal sign creates a variable and causes that variable to refer to some value. A pound sign, or a sharp sign, or a hash sign, or whatever you want to call that guy, indicates a comment. And everything from that pound sign to the end of the line is going to be ignored. So if I say B gets 123, pound sign, set B to refer to 123, all that stuff that I typed from the pound sign to the end is simply ignored. And I have now created this variable B referring to this integer value 123. If I say X gets 127, that's creating a variable called X, referring in this case to a float value, a floating point value, 2.7. I can define a string in Python by using double quotes around a sequence of characters. You can also define a string in Python using single quotes. There are various ways of defining a string that we'll get to as we progress. All right, so here I'm saying X gets 2.7. All right, so there's X, and S gets, what did I say, high. So there's S. Now, interestingly, notice that when I display the value of S, what gets displayed to me is high in single quotes. Single quotes is simply an alternate way of defining a string. So I could have said S gets high in single quotes, and that would also cause S to refer to a string high. So the single quotes, the double quotes are just alternate ways of defining a string. In this last one here, I'm using true as my value. Notice that's true with a capital T. And so B here is a variable referring to a Boolean value. And the other possible value is false with a capital F. If you try to say true with a lowercase t, you'll get yelled at because true with a lowercase t is considered to be some other reference to something else unrelated to true with a capital T. And Python is telling me, you know, hey, I can't find anything named true with a little t. Everybody good so far? Comments, assignment, int, float, stir, and bool. Okay? Now, so I've created some variables, but I haven't really told you what the rules are for legal variable names. It turns out that to create a legal variable name, the first character has to be either a letter or an underscore. And the letter can be either uppercase or lowercase. Uppercase and lowercase letters, as in other languages that you have encountered, are distinct. Okay, so capital A is not the same thing as little a in a variable name. Following that first character, which has to be a letter or an underscore, you can optionally give 0 or more letters, underscores, or decimal digits, that is base 10 digits. Okay, so if I say, so I already have this variable A that's referring to 123. If I say A gets 34 with capital A, that's a different variable completely unrelated to little a. I can say underscore 3 gets 9. So now I have this variable underscore 3 referring to 9. You should probably be fired if you do that. But underscore 3 is a perfectly valid variable name. Underscores are often used if you want to create a long variable name that you want to split up into separate pieces or separate words. All right, so I can say has 3 apples is true, and I now have this meaningful variable name, has 3 apples, that's relatively easy for some other programmer looking at my code later to understand what I'm saying. Good. You can't do something like saying 4 gets 5. Okay, 4 is not a legal variable name, so you cannot attempt to modify 4 to be the same thing as 5 this way. Also, you can't use things like dollar symbols in variable names. In Perl, you would have to use a dollar sign to create what's called a scalar variable. How many of you have ever written code in Perl? See, this delights me enormously, because 10 years ago, if you became an expert Perl programmer, you were set for life. You had a career that was going to the horizon if you knew Perl. Nobody uses Perl anymore. Let this be a warning. Now, Python, I suspect, is going to have a much longer life than Perl ended up having. Also, be careful not to try to use dashes in variable names, because the dash is actually the minus operator, the subtraction operator, and so if you try to do that, it won't work. These 4 variables up here, little a, little a, big a, little a, big a, are 4 completely unrelated variables. And again, if you write code with variables like this, you should really be fired. I had the exciting task as a very young programmer of writing a numerical integration program in a version of BASIC that was restricted to 2-character variable names. And let me tell you, that was fun. But fortunately, now you can have variable names that are as long as you want. It's always good to choose meaningful names. Okay, now, you can use, let's see, so I have a variable a, I have a variable big A, I have s, I have x, I have b. You can use a function, a built-in function called type, that will tell you what type of object the variable refers to. So if I ask for the type of I get, do I have an I? I'm not sure I do. If I ask for the type of A, I get told that A is referring to an int. If I ask for the type of S, I get told that S is referring to a... Now, okay, the technical built-in type name for strings is stir. So S is referring to a stir, but I can't bring myself to call things strs, so I'll tend to just call these things strings anyway. But the technical data type for strings is stir. The type of X is float. The type of B is bool. It turns out that unlike C++, Java, or other languages that you're probably familiar with, variable names in Python are only names for things. The things that those variables refer to are what have the type. The variable does not have a specific lasting type like it would in a C++ or a Java program. So if I say I get 123, that means that I right now is referring to an int, but I can say I get 3.456, and that's fine. I don't get complained at. And furthermore, that doesn't get truncated. Now, if you were in C++, now I have written Java code for money, but it's been years. It is true that if you assign a floating point value to an integer, that the fraction goes away, right? Okay, so that's the case in C++ as well. But in Python, all that's happened is that the reference I has been modified to refer to a float instead of referring to an int. Okay, and I can say I gets howdy, and now I is referring to a stir, and I gets false, and now I is referring to a bool. All right, so variable names are just names. Variable names do not have types directly associated with them. It's only the objects that these variables refer to that have types. So far, so good? Okay. Yes?
Does the variable get dropped if we change the pointer?
Excellent question. So when I said I gets 123, what that does is to cause the int value 123 to be stored somewhere in memory. Actually, because I was lazy, I already had the variable a referring to 123. So 123 is already sitting in memory, sitting in my data area somewhere. A is referring to it, and then I made I refer to it as well. When I say I gets 3.456, that creates data area. That creates a chunk of data containing the float value 3.456. Now 123 still has the name A referring to it, so 123 still exists in memory. But later, when I say I gets howdy, there is no other variable referring to this floating point value 3.456. So Python, behind your back, in the same way that Java does with garbage collection, Python will deallocate that storage containing the 3.456. Okay, so values that no longer have any references to them are reclaimed to be used so that their space can be used later. Is that sufficient? Other questions? Okay. So here are the 6 low-level so-called scalar types that we will be using in this course. There are a couple of other ones that are very uncommon that I'm not going to bother to mention, but these are the 6 that we will care about, and we've already seen most of these. Int contains an integer value, and what's cool about Python, right, there are many things that are cool about Python, but one of the things that's cool about Python is that ints in Python are arbitrary precision. You can create int values that are as enormous in magnitude as you want, either positive or negative, depending on how much memory you have on your machine. Okay? Float in Python is a 64-bit double precision floating point number. So in other words, float in Python is equivalent to double in C or C++ or Java, which if you have to move back and forth coding in different languages, this can drive you a little bit bonkers. So float is a 64-bit floating point number. Double is not a data type in Python. Okay? Now this means that the magnitudes of values and the range of and the amount of precision that you can have in a float is restricted, unlike integers that are completely unrestricted. Okay? A stir contains UTF-8 character set strings. Now, for our purposes, being in the United States, having this very simple character set, the so-called ASCII character set is a direct subset of UTF-8. So all of the keys, all of the characters on a standard American English language keyboard can be put into a stir. Bytes, I'm just going to tell you that bytes exist. We're not really going to use them. But these are this is a data type that allows you to keep track of binary data. Bool only has two possible values, true with a capital T, false with a capital F. And then there's also none with a capital N, which is the empty value, the non-existent value. It's equivalent to something like a null pointer in C++. Remind me what the equivalent thing in Java is? I'm sure there is something. Anybody know? Maybe I'm mistaken. Just 0, maybe? I don't know. Anyway, okay, so those are the 6 bottom-level scalar types that we'll be making use of. And on these things, in order to get something interesting to happen, of course, you, at a minimum, need to know how to do arithmetic computations. I'm usually clever enough to put in a cough drop before I start, but actually maybe I did and maybe it melted. Okay, so here are the arithmetic operators that exist in Python. And these are similar to Java and C++, but not exactly the same. For example, the highest precedence arithmetic operator in Python is **, which is an exponentiation operator. Then we have multiply and divide and modulus. But in Python, we also have something called floor division, which gives you the remainder after division of 2 integers. And then at the bottom level of precedence, we have the binary addition and subtraction. Now, plus and minus can also be used in a unary fashion, that is, with a single argument after it rather than 2 arguments on either side of it. And when a plus or a minus is used in this unary fashion, it has higher precedence than everything except for the **. It won't surprise you to learn that you can use parentheses for grouping and for modifying the precedence of these things. All right, so let me show you several examples. 2 ** 10. This is an integer, 2 to the 10th power, which everybody should have memorized as 1024. I'm kidding. If you don't have that memorized, that's okay. 2 to the 20th power is 1 meg. 1,048,576. 2 to the 30th power is 1 gig. 2 to the 40th power is 1 terabyte, etc., etc. And as I said, ints in Python are arbitrary precision. So I can ask for 2 to the 2,000th power, and that may take a blink of an eye to calculate, but it's totally fine. And there we are. Okay, so I can store and represent 2 to the 2,000th power. I can even store 2 to the 100,000th power, but I'm not willing to wait long enough for that to display on my screen. So trust me, I can do it, but I'm not going to do it. Now, if the exponent is a floating point number, then you get a floating point result rather than an integer result. All right, so 2 to the 0.5, of course, is the square root of 2. And so I get 1.414 followed by various digits here. The default behavior in the interactive shell in Python is to display to you as much precision as is available for the floating point number. But that precision is limited. I think it's 16 characters. I'm not going to count. You can count on that last character there as being a round-off error. So that last character is going to be garbage for sure. And if I compute something like 7/3, notice that that last character 5, well, that's obviously an error. Okay, so the 2.3333 stuff makes sense. 5 is just a round-off error in that division. If I try to say something like 2 to the 2000th 0.0 power, okay, this is no longer going to be an integer result. This is going to be a floating point result because I've used a floating point number as my exponent. And this number is going to be too big to fit within a float. So I'm going to get yelled at here that I have an overflow. All right, so this is, now, I mean, this is sort of a fact of life that you're used to in languages like C and C++. You know, you're used to having overflow and underflow problems and round-off problems with floating point values. What's different about Python, which makes this sort of seem annoying, is that integers don't have this problem. Integers can be arbitrarily huge in either positive or negative directions. Okay. A negative exponent is also going to result in a floating point value, even though in this case both arguments, the 2 and the minus 100, are both integers. Nevertheless, 2 to the minus 1,000th power is a floating point number, because of course that's the same thing as 0.5 to the 1,000th power. And this is small enough to fit. If I go much beyond an exponent of, if I go much more negative than minus 1,000, I'll eventually hit the lower limit on the magnitude that I can store. So, everybody good with the exponentiation? Okay, now the Unary plus in effect means to give you the value in the positive direction. So plus 2 is 2. Yay, big surprise. This is probably the one and only time you'll ever see the Unary plus used in your life. But it's in there just to have symmetry with the Unary minus. And the Unary minus, of course, is an important thing because it allows us to express negative values. From C++ or Java or other languages, you might be familiar with, come back here. The increment and decrement operators. For example, if I say, if I display A is 123, and so you might assume that A++ ought to give me a value of 123 and then change that to 124. But that's not what happens. There simply is no increment or decrement operator available in Python. So you can't use the plus plus or the minus minus. A plus plus is the same thing as saying A plus plus, and Python has no idea what that means. Parentheses here can be used to cause the addition to happen prior to the multiplication, or the subtraction to happen prior to the division. Now, when you use division with the single slash, you always get a float. All right, so if I say 5 over 2, unlike how things work in Java or C++, where that would give you back an integer 2 and the fraction is just thrown away, in Python, division always gives you a float every single time. And even if I say 4 over 2, I get back a floating point 2.0. Even if I say 3 over 1, I get back a floating point 3.0. Okay, so most of these operators will take into account the data types of the two operands, and if both of them are ints, you get an int as a result. If one of them is a float, you'll get a float as a result. If both of them are floats, you get a float as a result. But in the specific case of division, division always produces float, period, end of story, no matter what the types of the two operands are. Okay? Now, the equivalent thing to integer division in a language like C++ or Java, where the fraction just gets thrown away, is what's called floor division in Python. All right, so if I say 5 divided by 2, that's 2.5 as a float. If I say 5 floor divide by 2, that causes the fraction part to be truncated toward minus infinity. So 5 floor divide by 2 gives me an integer 2. Now, in C++ and Java, integer division truncates towards 0, correct? So if you have a negative integer and you divide it by another integer, you'll get a number that's closer to 0. But in the case of floor divide in Python, everything goes towards negative infinity. So if I say minus 5 floor divide by 2, all right, we know the floating point result would be minus 2.5, correct? But it gets truncated down toward negative infinity, and I get an integer minus 3 as my result. I didn't invent this, sorry. The modulus operator gives you the remainder after division. And when you're doing modulus of integers, the remainder is always a positive number. All right, so 5 mod 3 is going to be 2. Minus 5 mod 3 is 1. Okay, because minus 5 is equal to 3 times minus 2 plus 1. And so 1 there is considered to be the remainder after the division. Okay, so we've taken a look now at the exponentiation operator, which has the highest precedence, star star. Then we've got the unary plus and minus, which just give you the same value back or the negative value back. And then at the third level of precedence, we've got these 4, collectively they're called the multiplicative arguments, multiply, divide, floor divide, and modulus. And then we also have addition and subtraction. Let me just do a couple. So, 5 plus 2, this is very exciting. 5 minus 2. Okay. And those are the lowest precedence operators. Now, if either value in an addition or a subtraction is a floating point value, you get a floating point result. So if I say 5 minus 2.0, my result is 3.0, not 3. Okay? Okay, now here, so these were, although I mixed in some other examples, but these on slides 13, 14, 15, for the most part, involved int operands on the operators. Here are float examples. If either the value being raised or the exponent, or both, in an exponentiation operator is a float, then the result is going to be float. And I've already described for you the problem that because floats have a restricted range, you'll often end up getting these overflow error complaints if you try to do something that results in a value outside the bounds of what will fit. Now, weirdly, you can do floor division of floats, and you'll get an integer float result. Okay, so 11 floor divide by 3 would be what, 3.666, whatever. And that fraction part gets chopped off, but the result remains a float. Okay, so we've dealt with numbers and arithmetic now. Any lingering questions? All right, next we're going to take a look at strings. And you can define a string, as I've said, in double quotes or in single quotes. And Python is equally happy either way. In output, in your interactive shell, Python will prefer, by default, to display things inside of single quotes. But even that is not guaranteed to always be the case. Sometimes it'll prefer to use double quotes instead. If I want to have quotes inside of a string, well, that's one of the advantages of having two different ways of defining a string. All right, so if I say double quote, single quote, hello, what I've done now is to define a string containing single quote, HELLO, single quote. All right, the double quotes define my string, and the single quotes here are just characters within the string. Similarly, single quote, double quote, hello, double quote, single quote, is a string containing a couple of double quotes. The plus operator and the times operator can be used with strings. Plus means concatenation, and times means repetition. So if I say hello as a string plus bye-bye as a string, I put a space in there ahead of the first B intentionally so that when I concatenate these, I get a single string with a space between hello and the first occurrence of bye. Notice here that I haven't created any variables to refer to these values, so I'm computing and displaying these values, and then the values are just disappearing. Okay? If I wanted these things to hang around, I should create variables to refer to them. And if I say S3 gets S1 plus a space plus S2, now S3 refers to that concatenation of hello followed by a space followed by bye-bye. Good? Star means repetition. So if I said ABC space times 5, what I'm going to get is a single string containing ABC space concatenated 5 times. Okay? This is really handy if you're trying to display a report and each of the columns in the report is 8 characters wide. You can say something like dash times 6 dash times. Sometimes I get myself tricked into doing overly elaborate examples. This is one of those cases. So dash times 6 plus space times 2 times 5. Oh, isn't that amazing? Okay, so I got 6 dashes and 2 spaces, and I've repeated that pattern 5 times to create, underscores for the headings on my table. Everybody good? Okay. Now, in addition to using a pair of single quotes or a pair of double quotes, you can also use a pair of triple single quotes or a pair of triple double quotes to create a string. And furthermore, with these versions of the string creation, you can have multi-line strings. Okay, so all right, so I can say SA gets hello in single quotes, SB gets hello in double quotes, SC gets hello in triple single quotes, SD gets hello in triple double quotes, and these four variables refer to equal values. In fact, the equality test is the same in Python as it is in C++, Java, C, lots of other languages derived from C. So if I say SA is equal to SB as a test, I get told, yeah, that's true. SA is equal to SC. Yeah, that's true. SA is equal to SD. Yeah, that's true. So these are four different ways of defining a string of 5 characters, HELLO. All right? But with the triple single quotes or triple double quotes, I can say this is a multi-line string, blah, blah. And I've put an empty line in there. All right, so this string has 5 lines in it. And if I display the value that mult refers to, what I'm going to see in the output is this character \n. Well, it's 2 characters, of course, in the output, but it represents a single so-called new line character, which is the character that you use in Python, just like in C or C++ or Java, to indicate the continuation onto the next line down. So I've got a new line between and multi-line, and between string and blah blah. Here I've got 2 new line characters to account for the blank line that I had in here. All right, so this is 5 lines, and the 5 lines are separated from one another with 4 new line characters. So far, so good? Yes?
Why do we need triple single quotes instead of double single quotes?
Why do we use triple single quotes instead of double single quotes? Is a good question. Off the top of my head, I can't think of... I presume that when the language was being developed, there was some example, some obscure example that came up that caused the BDFL, Guido, to decide to use triple single quotes or triple double quotes. Off the top of my head, I can't think what that is. I can't think of an example.
Probably for a multiple line comment.
Pardon me?
Multi-line comment.
Not comment, if you want to write, like if you're using only 2 colons over there and if you're writing a statement, it will show you an arrow. And but if you want to go to the next line, it works for the 3 colons over there.
Okay. Okay, so I'm not sure I fully understood. Does that explain why you need to use 3 single quotes, or does that explain, what goes wrong if you don't?
Maybe it can be mistaken for an empty string, for example.
Oh, duh. Yay. Yeah, so that could be mistaken for an empty string. But, why isn't this just mistaken for an empty string followed by hello followed by another empty string? Okay, so it's just a rule. It's just a rule. Okay? All right. All right, so here are the examples I just did on slide 20. So we've got int, we've got float, we've got stir. Bool, as I said, only has two possible values, true with cap T, true, false with cap F. Now, we talked about the precedence of the arithmetic operators. I said that star star had the highest precedence, followed by the unary plus and minus, followed by the multiplicative operators, and then the additive operators, plus addition and subtraction. As far as associativity, it turns out that almost all of the arithmetic operators associate from left to right, with one frustrating exception. The star star associates from right to left, not from left to right. So that means that if you say something like 2 star star 3 star star 2, well, you look at that and you're used to these arithmetic operators being associated from left to right for the most part. And so you glance at this and you say, oh, okay, I get it. That's 9 squared, so my result should be 81. Well, no, it's not 81, because what it is 2 to the 9th power. All right, so the implied parentheses are around the 3 star star 2 because of the associativity being right to left. And so what I get is half a k, all right? Should be immediately obvious that that's 2 to the 10th over 2, right? Okay, so this is 2 to the power of 3 to the power of 2. And the exponentiation on the right has precedence. If you want to force the one on the left to have precedence, you have to use the parentheses to force that, and this will give us the, what'd I say, 81? Yeah. So I probably said, so when I said 81, probably everyone was confused. Yeah. 2 cubed is 8. Not 3 squared, which is 9. So 2 cubed is 8, squared is 64. Good? Okay. Okay. Just like Java and C++, for convenience, in Python you can use these so-called assignment operators, consisting of an arithmetic operator immediately followed by an equal sign. So if I have A gets, well, A is already probably 123, all right? And if I say B gets 4, then if I say A plus gets B, that's exactly equivalent to saying A gets A plus B. Okay? Or if I say A floor divide gets B, that's exactly equivalent to saying A gets A floor divide B. All right, so 127 over 4, that's going to be 124 with the 3 is going to be thrown away, so 124 is going to give me 31, I think. I did arithmetic in my head once successfully. Yay! You'll never see that again. Everybody okay with these assignment operators? Now remember that you can use plus and times with strings. So if I say S1, S2, I can say S1 plus gets S2, And this is equivalent to saying, if I could type, S1 gets S1 plus S2. So S1 now refers to hello, bye-bye. And of course, there was no space in there. I should have been smart enough to put a space in there as well, but I didn't. Or S2 times gets 5. S2 times gets, I say times and type plus, is concatenation. So now I have S2 modified to be itself concatenated together 5 times. Yes?
So it looks like on the left hand side it gets repeated, so whenever it is added or you use any of the operators, could it potentially do that with more than one variable on the left hand side?
You can. On the left-hand side of an assignment operator. Okay, partly what you're describing is something called sequence unpacking, which does allow you to have multiple variables on the left-hand side of an assignment. And that's ahead of the game a little bit. The second half of your question about whether you can use an assignment operator like this with multiple variables on the left, I've never tried that. I'm not sure whether it works. So let me punt for now. And when we talk about sequence unpacking, if you can remember to remind me, I'll try to answer then. I think the answer is no. Sorry. But maybe the answer is yes. Okay, so those are scalar data types. We've got integers, floating point numbers, strings, booleans, and often we need to create collections of those things, like arrays or lists or structures or sets or what have you. And there are many built-in collection types in Python. We're going to start out by taking a look at the list collection type, and then introduce more of these things tomorrow and next week. A stir also, in certain contexts, can be treated as a collection of, or a sequence of, character values. Okay, so to define a list is sort of vaguely like an array in languages like C and C++ and Java, but it's more flexible than an array, because an array in these other languages have fixed size, whereas a list in Python does not have fixed size. It's actually variable size. You can define a list using a pair of square brackets containing a sequence of items separated by commas. So here we have an example of a list of 4 ints. I'm saying M gets, and I don't suppose it matters if I use, 7230 just to be consistent, 7230. All right, so the variable M now refers to a list of 4 int values. And I can ask for the type of M, and I'll be told that that thing is a list. To access individual items within this list, I use the square brackets as subscripts, and I can use indexes from 0 up to 1 less than the length. So M sub 0 is going to be the 7. M sub 3 is going to be the 0 out here at the end of the list. And if I try to access an item that's outside the bounds, like M sub 4, in Python I get yelled at. Now in C++, that just, something happens silently, and probably that's going to cause problems to your program later. Does Java complain if you go outside the bounds of a list? I forgot. Array? I forgot. Sorry?
Index out of one.
Cool. All right. All right. I knew that Java was worse than C++. All right. Forgive me. See, but checking for boundary conditions takes time. You don't want to take time. You just want to be a smart programmer and not make any mistakes. This is what C++ programmers claim. And C++ programmers are obviously idiots, but whatever. So Python complains that I am outside the bounds of my list here. Now, it turns out I can also, in Python, use negative subscripts to access items from the end working backwards toward the beginning. So no matter how long my list is, the sub -1 element is going to be the last item in my list. Let me just display M again before it goes off the top of my screen. All right, so M currently contains 4 items, 7230, and M sub -1 is the last item. M sub -4 is the first item. All right, so I can count through the list forward from 0 to n-1, or backward from -1 to -n. But if I try to go too far backward, I'll get the same out of bounds complaint. Okay, so I've done these examples here on slide 26. Now, items in a list can be modified. The technical word for this is that a list is mutable. That is, items within a list can be changed. And I can do this, for example, just using an assignment. So if I say M sub 2 gets, what's the value? 5. Okay, well, M sub 2 currently is the value 3, and I'm just going to replace that value 3 with a 5. Whoop. So now M has a 5 in the third as the third item rather than a 3. Addition and multiplication work for lists the same way that they work for strings. That is, addition of 2 lists will give you a concatenation of the 2 lists. Multiplication of a list by an integer will give you that repetition of that list that many times. So here's M, and if I say M plus 471, the list M is going to have, all right, we're going to get a copy of the list M, and we're going to concatenate onto the end of that the list 471. So the result is 7250471 as a list. Did this change M? No, I just got the value of M. I appended another list to it. I displayed that list, and now that list has disappeared. M is still what it was. M has not changed. If I wanted to save that modified list, I could have said something like M2 gets M plus 471. Okay? Or I could have said M plus gets 471, which, recall, is the equivalent to saying M gets M plus 471. All right, so in that case, I did fetch the value of M, which is a list of 4 items. I concatenated 3 items onto that, and then I modified the reference M to refer to that new list. My old list, which was 7250, has now been forgotten. That list is gone from memory. Okay, now the star gives you concatenation. So if you want 1,000 zeros, you can say, give me a list of a 0, but give me 1,000 of those guys. And this will give you a list of 1,000 zeros. No problem at all. Okay, it went flying off the top of my screen, but it worked just fine. So far, so good with lists? Okay. In addition to using the square brackets for subscripting within items in a list is a class, actually, that has named methods, named operations that you can apply to it, as well as using the subscripting. For example, we can append a value to the end of a list. We can insert a value at an arbitrary position within the list by specifying both the index where we want the value inserted and the value. So, for example, here's my m. If I say m dot append 8, now m has increased in length by 1 and 8 is at the end. Or if I say m dot insert at position 0 and 8, now I have inserted an 8 at the beginning of the list, and the list has grown to 9 items. Okay? If I say m dot insert 4, let's see, where is this going to insert? Well, I need to give a value. If I say m dot insert 4 comma 8, where is that going to insert the 8? Ahead of what? The 0, correct, good. Because the 0 is item sub 4. Remember that indexing starts from 0. So m dot insert sub 4 comma 8 is going to insert 8 ahead of the 0. On the other hand, if I say m dot insert sub minus 4, oh, let's be wildly different here and insert a minus 8. So minus 4, what's that going to insert a minus 8 ahead of? The 4, right, because remember that the last value has the subscript minus 1, so minus 2, 3, 4, that's going to insert the minus 8 ahead of this 4. Okay, and so each append and each insert that I do is increasing the length of the list by 1 item. I can remove a particular value from the list, and that's going to remove just the first occurrence. So if I say m dot remove 8, only the first 8 is removed. If I say m dot remove 8 again, this is the first 8 in the modified m, so that's the 8 that's going to be removed. I can also pop an item from the list. In effect, what I'm doing here is I'm treating the list as though it were a stack. Now, by default, popping with no argument is going to remove the frontmost item from the list. No, obviously I meant the last item. Sorry. Okay, so popping removed the last item from the list. And so there I got the 1. You can pop an arbitrary item by specifying its index. So if I say pop 2, well, that's not actually going to pop the 2. It's going to pop the sub 2 item, so it's going to pop the 5. Okay? I can count how many times something occurs. I can also sort the items in ascending or technically non-descending order. So if I say m dot sort, then minus 8 becomes the first value, and notice that I have 2 7s out at the end. If I say m dot reverse, that does the obvious thing. It just puts the items in the reverse order. Yes?
So just like we added values by like index, could we also remove values from it?
That's what pop does. Yes. So so here's m. If I say m dot insert 4, 9, okay, sub 4 is going to be the 0. So that's going to insert a 9 ahead of the 0. And if I now say m dot pop 4, well, now the sub 4 item is this 9, so that's going to pop that same value from the list. Other questions? Okay. Here are examples similar to what I've already talked about. Oh, this is so cool. This is exactly where I wanted to stop. And I've only got 1 minute over. Any remaining questions? Okay, cool. So we will finish this material on Thursday. I will, meanwhile, I already did post homework 1. Homework 1 asks you to read and try various experiments from the whatever that textbook is called. I've forgotten now. So I'm going to assign partners. Now, for this particular homework, you each just need to independently do what you're asked to do, and then just check with each other to make sure that you both agreed on what you did, and then one of you will submit. And I will see you on Thursday. If you have any questions, shoot me an email, and I'll be happy to answer. Okay.